Okay, so the next thing we're going to talk about is what is called compound probability. So with simple probability, we were talking about like one outcome. So you're rolling one die. What are the chances this will happen? So we're going to say that I can calculate compound probability with an area model. So kind of the next few things we're going to talk about with compound probability are different ways to visualize the different combinations. I'm getting ahead of myself, but it's different ways to visualize it. So compound probability is the probability of two or more events happening at the same time. So like when we're talking about the bag of marbles, what's the probability of getting blue or green? That is different than blue and green, right? The and means that they're happening at the same time, but or means I'm okay with either option as long as I get one of them. And a really common one is you're rolling two dice, right? And they both land on the same number, or they land on this combination of numbers. Okay, so it says, when finding the probability of just two events, we can use what's called an area model to help us list all the outcomes. And right here are kind of the steps. So it helps to, let's add this before. Read and prepare, how about that? So you need to read the problem, kind of figure out how much space do I need, what might it look like. We're going to draw a rectangle, list all the possibilities for the first event on one side, or I should say side, haha. And then you're going to list the possibilities for the second event on the top of the rectangle. And then you're going to write down what the combinations are. So I've provided the rectangle for you on this first one so you can see an example, because it does take some pre-planning. So it says, there are 2 cups with candies in them. The first cup has red, pink, and yellow candies. The second cup has red, orange, pink, and yellow candies. And we're going to list the sample space. In probability, the sample space is the list of outcomes. So from this table that I've made, the area model, you can see that, okay, on this side, the first one had red, pink, and yellow. So I listed those on the side. The second one had red, orange, pink, and yellow. So I listed those on the top. So in each box where they meet, so I'm going to use R for red. So if I'm choosing a candy from each cup, I can pick red from the first cup, red from the second cup. And the order matters on these, okay? So then if I go one over, I could pick red from the first cup and orange from the second cup. I could pick red from the first cup and then pink from the second cup. Then I could have red, then yellow. Going down to the next option, I could have pink from the first cup, red from the second one, pink from the first one, orange from the second one. I could get pink from the first and the second one. And I could get pink then yellow. I might use black for yellow just because that color is hard to see when you're reading it. So then the last row, you could get yellow from the first cup, red from the second, yellow, then orange, yellow, then pink, yellow, then, double yellow. yellow. So you're seeing, okay, if I have pink from the first cup and orange from the second cup right here, that's the combo they make. All right, so looking at how many possible outcomes are there. So you just count the number of things you made. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possible outcomes. What is the probability you choose 2 pink candies? Well, the probability of double pinks is, then I'm going to go look at the sample space I made, and I only see one outcome that has 2 pinks. So there's one of them out of 12 total is double pink. So then the probability of red, then pink, so I see 1, well, it says and pink. So as long as it's any combination of red and pink, then there's another one. There's 2 options that have red or pink. So 1 in 6 chance. So you gotta kind of pay attention to that language of, does it mean in this specific order, or does it mean any sort of combination of this? All right, next one, and we're gonna practice drawing it. So this says, in a game, you flip a coin. So the 2 options when you flip a coin are heads and tails. And you roll a normal 6-sided die. So that's numbers 1 through 6. So the first thing we do is flip a coin. And the options are heads or tails. The second thing we do is we roll a die, and the options are 1, 2, 3, 4, 5, and 6. So I'm going to draw an area model. So the combinations are that it lands on heads and the die lands on 1. The coin lands on heads, the die lands on 2, heads 3, heads 4, heads 5, and heads 6. Then the bottom row is that the coin could land on the tail side, and the die could land on 1. The coin could land on the tail side, the die could roll on 2. So what the area model lets us do is just, it helps us make that list. We could go through and think through that list, but we might miss one. So this just keeps it organized. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. The probability of the coin landing on heads and an odd number, so that's 1, 2, or 3. Oh, no, 1, 3, or 5. So here's heads with an odds number. Okay, those are 3 options. 3 ways for that to happen out of 12 ways possible, which that's just, if I divide them both by 3, I can reduce that. 1/4, or 0.25, or 25%. So remembering that probability can be represented a bunch of different ways. So what is the probability that the coin lands on tails and that the die lands on 1? So I see, one combination of that. So one option out of the 12 Oh, and I don't have a calculator on me. Give me 1 second. Right. All right. 0.083, repeating, rounded to the nearest hundredth. So we find our place, we look next door. The number next door is 4 or less. So the one we round gets to rest. All right, so for the practice, plan out like about how big you think the space will need to be, how many options are there for the first one, how many are there for the second one, and then write the combinations, and then you can use the written combinations to find the probabilities.